Okay, good morning. Welcome to
Awesome Math number 9.
Awesome Math number 9. Now, what did you do this morning?
I calculated up all of the primes between 1 and 200.
Okay. Doing what? How'd you do it?
The Sieve of Eratosthnes.
Sieve of Eratosthnes. Okay. So it starts out 2, 3, 5, 7, 11, and then keeps going, right?
Yeah.
Okay. Now, one interesting thing, and I just wanted to connect this back to number theory to see some interesting number theory questions, and I'll tell you some other really famous questions about primes. Okay. Right in the beginning, we see 3 odd numbers in a row that are primes.
Yeah.
3, 5, and 7. I know this won't be on camera, but do you ever see that again? Do you ever see 3 odd numbers in a row that are primes?
Not on the list we made.
Doesn't seem like we do. I wonder why. We do see pairs together,
Yeah.
like 3 and 5, that are just 2 apart.
Yeah.
5 and 7. Can you see on your list what the next set that's just 2 apart is?
I think it's 11 and 13.
11 and 13. What's the next one after that?
13. Well, the next one is 29 and 31.
And I think there's one before that.
There is?
Yeah.
You mean they don't have to be they don't have to be one apart?
Yeah, just one apart. So one number in between them. But there's one before 20,
Oh, 17 and 19.
17 and 19. What was the next one you said?
I think it was 29 and 31. They're getting less and less frequent.
Ooh, interesting. It does seem like they get less and less frequent. But here's the thing. This is an unsolved problem. Remember how we talked about there's an infinite number of primes?
Yeah?
No one knows if there's an infinite number of, these are called twins. Just one apart.
Yeah.
These are called twin primes. Nobody knows.
Yeah.
If you solved this problem, if you figured out if there were an infinite number of these or not an infinite number, like there was a highest twin prime and there were no more twin primes after that, you'd be famous.
I know there's infinite pairs of primes that can be infinitely apart.
That's true.
Yeah.
Okay, but let's go back to this question. Are there ever any more primes that are 3 odd numbers in a row? So we found lots of twins.
Well,
I wonder if there are any triplets. And this is a question that you can actually understand this. Okay, so we start with 3 odd numbers in a row.
yeah.
Okay.
So we didn't see any on our other list.
No, we didn't see any. So let's see. What if we start with a multiple of 3 like we did here?
Well, maybe 6.
Like this is 3n.
3.
Okay. So it's not going to be a prime, right? Because it's divisible by 3. What would the next number be if we're going to look at the next odd number? Would it be, how would you write the next odd number?
Maybe 5n. Well, you said the next odd number.
Yeah, the next odd number. This is going to be an odd number, and it's going to be a multiple of 3.
3n plus 2.
Very good. 3n plus 2. And the next one would be what?
3n plus 4.
3n plus 4. And these would be 3 odd numbers in a row.
Yeah.
But this could never be prime, except in this case, because if when I start with a multiple of 3, it's not prime unless what?
Unless it's not a multiple of 3.
Well, it is a multiple of 3. And so since it's a multiple of 3, it's never going to be prime except for one situation, which is...
This case.
What's that case?
It's 3, 5, and 7, which is the starting multiple.
Okay, very good. Okay. Now, so we know we can't start with a number that's a multiple of 3, except in this case.
Yeah.
Okay, so I have to be either have a remainder of 1 when you divide by 3, or a remainder of 2 when you divide by 3. So it's going to be 3n plus 1, maybe?
Yeah.
Then 2 more than that would be 3n plus 3, and 3n
plus 5.
plus 5. Do you notice anything interesting about this number?
Well, 3n plus 3 would, well, maybe it could be this. I don't think that could add to that.
It won't add to it, but there's something interesting about this number.
3n plus 3.
There's a number that's going to divide that number.
That can, well, you can cancel the 3's.
Well, factor them out.
Yeah.
3 times n plus 1. That's a multiple of 3. So if the first number is a multiple of 3, we're not going to get 3 in a row. Because this won't be prime except for the first case. If the first number has a remainder of 1 when you divide by 3, the second number will be divisible by 3.
Yeah.
And if it has a remainder of 2 when you divide by 3,
Probably the third number.
why is 3n plus 6 divisible by 3?
Well, you can factor out a 3, it would be 3n plus 2.
Third number will be.
Cool.
Okay?
Wow.
Okay. So this is the only one. Because either the first one's a multiple of 3, the second one's a multiple of 3, or the third one's a multiple of 3. Pretty neat, right?
Yeah.
So there's only one set of 3 in a row, odd numbers. But there might be infinitely many.
2 in a row.
2 in a row. Pretty cool though.
Yeah.
Alright, sweetie pie. Good job with your Sieve of Eratosthnes this morning. Good job.